Well, hello and welcome to this exercise on direct and inverse proportion or direct and indirect proportion, depending on where you are. Now, this is part of functional mathematics curriculum for GCSE, that is. So it should be okay for iGCSE and for high school GED mathematics. And it's a very lengthy question, so you might have to pause the video and go through the question again. But I should try and be as explicit as I can. And it says a small food company estimates that its profit is directly proportional to the square root of the number of pickers or number of workers, and indirectly proportional to the square of the time taken for breaks. Now, in this season, its profit, it made a profit of $6 million, quite a profitable fruit. It made a profit of $6 million, so the number of pickers was 16 persons. And the total time taken for breaks was 3.4 weeks. Now, next season, the company wishes to increase its workforce to 20 and to maintain the profit at the same level. So it wants to find what the break time weeks should be per picker in order to make this in order to keep the profit the same. So it wants to reduce the break time weeks per person to keep the profit the same. And then it says calculate the percentage difference in the fraction of break time weeks per picker this season and the estimated break time weeks per picker the next season. Okay, now if we then say let P be profit, W be the number of pickers or the number of workers, and T be the number of break time weeks, then the profit is proportional to the square root of W and inversely proportional to T squared. If we now remove the proportionality sign and replace it with equal sign, we then have that P is equal to K times the square root of W divided by the square root of T, divided by T squared. K is now the constant of proportionality. Okay, now if you replace this with numbers, we end up with 6 times 10 to the power 6 is equal to K times the square root of 16 divided by the square root of 3.4 squared. Now, I could have left this 10 to the power 6 out, and that would make any difference to the final result, but I should leave it in for now. Okay, so if we now make K the subject, we don't have that K is equal to 6 times 10 to the power 6 times 3.4 all squared divided by the square root of 16. So K is now equal to 69.364 times 10 to the power 6, which is, and K is then 17.34 times 10 to the power 6. That's the K value. Now, we shall use this K value to calculate, or to help us calculate, the T value for next season in order for him to make the same profit as for this season. Okay, so now we have that 6 times 10 to the power 6 is equal to 17.34 times the square root of 20, 20 being the number of pickers required for next season. We're looking for T times 10 to the power 6. Now, the 10 to the power 6 on the left hand side and the 10 to the power 6 on the right hand side will cancel out. Okay, so we now end up making T squared the subject. We end up with T squared is equal to 17.34 times the square root of 20 divided by 6, and that gives us a T squared value of 12.9244. If we then take the square root of both sides, the square root of T squared is T, and the T is equal to the square root of 12.9244, which gives us a T value of 3.595. Now, to one decimal place, that would then become T is equal to 3.6 break time weeks for next season. So this is what we require in order for the company to make the same profit next season as it did this season. Right. So now for this season, if you say 3.4 times 100 divided by 16, because 3.4 is the break time weeks for this season, and 16 is the number of workers. That gives us at 21.25% per worker. In other words, 0.21 break time weeks per picker for this season. And next season, this ratio becomes 18%. It's equivalent to 0.18 break time weeks per picker in order to make the same profit next season as we did this season. So that becomes an increase of, or a decrease of 3.25% in the ratio of break time weeks per picker. Now, I hope all that made some sense, and please subscribe. Thank you for watching, and hopefully see you again sometime. Bye bye now.